Hi everyone, in today's lesson we're going to talk about equations of circles and the different forms that they are in. So let's first recall a few things about circles. So given these three circles graphed below, could you tell me their center and could you tell me their radius? Well, finding the center, let's do the first one together. Finding the center should be relatively easy. You're just going to eyeball it, so it looks like right here would be the center, the coordinates of the center, and you just count over from here to find the radius. So that looks like it's 3 spaces. You could also find the radius by counting this way, right? Radius is half the diameter. So our radius is 3 and our center are the coordinates 1, 2, 3, 1, 2, 3. So the center is 3, 3 and the radius is 3. See if you could do examples 2 and 3. And then resume the video when finished. Okay, so your center for number 2 should be about here. And my radius is 1, 2, 3, 4, 5. If you count from here to here, my radius is 5. So my center is the point 1, 2, 3, so the point 3, 0. And my radius is 5. And the last one looks like the center is right there at the origin with a radius of 3 again. So center is 0, 0, and radius 3. Now, when we put this information into an equation, remember the equation of a circle is x minus h squared plus y minus k squared equals r squared. Now, h and k are simply the coordinates of the center, and the radius is the square root of r squared, which is in fact r. So whatever number would be here, you just take the square root of it, that's your radius. And do you see how the center is hk, positive h, positive k, and in the formula it's negative h, negative k? So you just have to remember to negate or switch the signs to find the center. So now what I want you to do is write the equation of each circle in center radius form. So remember, we have an h and a k, so if I'm going to do the first one, my h is 3, my k is 3, and my radius, r, is 3. So if I want to write this in center radius form, it's x minus something squared plus y minus something squared equals radius squared. So what goes in here for the h? The h is 3, the k is 3. So 3 and 3, and then my radius is 3, so 3 squared is 9. So the final answer would be x minus 3 squared plus y minus 3 squared equals 9. You always want to simplify that end problem if you can. Okay, let's do example number 2. So in example number 2, my h is 3 and my k is 0. So it's going to be x minus something squared plus y minus something squared equals something squared. So we know the radius is 5, so I can go ahead and put a 5 there. My h is 3, my k is 0. So if I want to simplify this, the problem will be x minus 3 squared plus y squared equals 25. How to get y squared is simply the fact that y minus 0 is just y, and that thing I'm squaring. Okay, now the last one, my center is 0, 0, and that's going to be my h and k. So again, it's going to be x minus something squared plus y minus something squared equals the radius squared. So my center is 0, 0, and my radius is 3. So this simplified is nice and easy. X squared plus y squared equals 9. Okay, now what if I give you the equation? Can you tell me the information? Okay, so the center is going to be the opposite signs of whatever it is in the equation. So in my equation here, I have x minus 4 and x plus 2. So when I put it in here, it's just my center is positive 4, negative 2. So again, whatever you have in here, negative 4 becomes positive 4, positive 2 becomes negative 2. And my radius is simply 2, because 2 squared gave me 2. Now my center here, x squared, we know from up here, that's just when I have a 0 as a coordinate. So 0, positive 6, and my radius is 3. Okay? All right, let's move on to the next page now. That was just a little bit of circle review. Now how about if I ask you to write the equation of a circle in center radius form, given a center and a point on the circle. So we know that we want to write the equation in center radius form. We know that that's x minus h squared plus y minus k squared equals r squared. And we know that h and k is my center. Well, it looks like I have a center right here. So remember, we put it into the formula as x minus h and then y minus k. You don't have to do what I'm doing here. You could just know to say x plus 1 squared plus y plus 1 squared. I'm okay with that. So now the only thing that's left to finish this problem is to know the radius. Now I'm just going to erase this. The problem is that we don't have a radius, and there's really no way for me to count it. Because if I were to count over, I have 1, 2, 3 and a half. 1, 2, 3 and a half. I mean, I'm guessing there that that's a half, and that's not good enough. What if I went up instead? 1, 2, 3 and a half. Again, it's not enough. So they're giving you this point right here, 2, 1. And they're giving it to you for a reason. Because technically, can I have a radius be this distance from here to here? So what is kind of cool about this is you could actually box out a Pythagorean theorem out of this. So here's a right angle from here to here. So I have enough information now to find this radius. So what are the amount of spaces that I go from this dot here to here? There's 1, 2, 3. So this distance down here is 3. What's the distance here? There's 2. So there's a 3 and a 2. So all I need to do is the Pythagorean theorem, and I have r. So 3 squared plus 2 squared equals r squared. So 9 plus 4 is 13. And 13 is equal to r squared. Now you're probably thinking I could probably take the square root of both sides, but that's actually unnecessary because what do I want? I want r squared, and this is r squared. So the answer is 13. So this is my equation. So just to recap what I just did here is that we wanted to write the equation of a circle in center radius form, given a center, so we go ahead and we plugged that in, that was good, but this point was given to us. We needed this point because I couldn't count over a nice whole radius. So I needed to find this distance between this point and this point to find the radius. And I used the Pythagorean theorem and I solved. Okay, now what if I ask you to write an equation in standard form? Standard form is just another way for us saying if I were to FOIL this out, and bring the 13 over and get it equal to 0, that's a different form. It's just, we call it, I don't know, expanded form if you want, but it's really just called standard. So if I say write the equation found in the example above in standard form, I basically want you to tell me x plus 1 squared plus y plus 1 squared is equal to 13 into this form here. So I want you to take x plus 1 and multiply it by x plus 1. I want you to take y plus 1 and multiply this by y plus 1. And then subtract over the 13 so that it's equal to 0. So take a minute, double distribute this out, and meet me at an answer. Pause the video until you've done so. Okay, you should get x squared plus 2x plus 1 and y squared plus 2y plus 1 equals 13. Now it looks like when we have it in standard form, they group the x's, then the y's, the x squareds and y squareds. So let's write it as x squared plus y squared, right? X squared, y squared. What comes next? X and y. So here's x, here's y. So 2x plus 2y. And if I add the 1 and the 1, that gives me 2. And then I have that equal to 13. I'm almost there because I have to set it equal to 0. So all I have to do now is minus 13 on both sides. So we get x squared plus y squared plus 2x plus 2y minus 11 equals 0. That is standard form. So honestly, this problem isn't necessarily difficult. It's more of just understanding what it's asking. It's asking you to write from center radius, which is this form right here, center radius, into expanded, just to write it all out. Now here's the hard part. What if I ask you to go from standard form to center radius form? That is what we're going to take care of on the next page. Okay, so again, I'm asking you to write each equation in center radius form and then tell me what the center is and what the radius is. So what this is involving is going to involve completing the square. It's not too bad, but we're going to group the x's first. So x squared plus 2x. We're going to group the y's next. So plus, I'm going to use two different colors, y squared minus 4y. And then we're going to move this 1 to the other side. So we're going to subtract 1. And 0 minus 1 is negative 1. So if you want to write down some steps, the first step is to group the x's, group the y's, and move the constant. Now the second thing you want to do is create two perfect square trinomials. Okay? Now, perfect square trinomials, remember, are found by taking half of b and squaring it. So, let's do it. So we're going to take, first off, this b is a 2, and then this b is a negative 4. So I'm going to write down the steps down here, color-coded. Half of 2 squared. Half of 2 is 1. 1 squared is 1. Now I'm going to do the blue one. Half of negative 4 is negative 2. Negative 2 squared is 4. So those are the two values that I'm going to add to both sides of the equation. So I'm going to take x squared and 2x, add some number, plus y squared minus 4y, add some number. Maybe I'll use the right colors. Equals negative 1. So if I'm adding 1 to this side of the equation, I have to add 1 to this side. And if I'm adding 4 to this side of the equation, I have to add 4 to this side. And now we just complete the square like regular. We were talking about the factors, and this is the trick here. 1 squared is the factors here. This is going to become x plus 1 times x plus 1. And this will become y minus 2 times y minus 2. Again, from here, that negative 2 tells me what are the two things. Equals. And then if we add all of these together, we should get 4. So what does it mean to multiply something by itself? You should be telling me squared. That thing squared plus y minus 2 squared equals 4. This is your formula of the circle in center radius form. And my center is negative 1, I've got to change the sign, negative 1, 2, with a radius of 2. So that's how we can use completing the square to find a center and radius form of a circle. All right, let's try example number 2. Okay, so first things first, we're going to group the x's just like we did before. So 4x squared minus 16x. Then we're going to group the y's. And we'll subtract that 50 over. Okay, now you should notice something different about this problem is that we have a leading coefficient of a 4 here and here. And you should be telling yourselves that you really can't complete the square until you get rid of that 4. So how we did it before was we would take out a 4 and we have x squared minus 4x plus, take out a 4, y squared minus 6y equals negative 50. So that step was a little different. We said take out the 4's. Now we can create a perfect square trinomial inside these parentheses. So we're going to add something to that one. We're going to add something to this one. Equals negative 50 plus something, which I'll put in red, plus something here, which I'll put in blue. So let's do the work to figure out what these numbers should be. So we're going to half negative 4. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And now we're going to do the same thing with the b value here, which is a negative 6. So negative 6 divided by 2 squared is negative 3 squared, which is 9. So over here, we're going to add the 4, and over here, we're going to add the 9. But remember, we're not going to add 4 and 9 here because we have to multiply. So this is going to be 4 times 4 gives me this one, which is 16. And then we're going to do 4 times 9, which gives me 36. So that's the only difference between the first problem and the second. So now the rest we're going to finish just the same. So when we factor this x squared minus 4x plus 4, we know that the factor is negative 2. So x minus 2 squared with the 4 in front plus 4 y minus 3 squared, I got that from here, equals, and now what do we do over here? We're going to add all of this together. And when you add it, you should get 2. So we're almost there. So the only thing is that we can't have these coefficients in front because then it's not a circle. A circle is x minus h squared, no number in front. So we actually can divide the entire equation by 4 to get rid of them. Everything. You divide all sides by 4. So these will cancel, and now you have x minus 2 squared plus y minus 3 squared equals 1/2. So now, if we ask me what the center is and what the radius is, we should be able to tell me. So the center is 2, 3. Again, I negated if it was a negative 2, I made it positive. Negative 3 made it positive. And the radius is simply the square root of 1/2. Because this 1/2 came from something squared. Now you can leave it like that. That's the final answer. You don't have to simplify it, but that's it. I know question number 2 is a little bit tricky, but at least get the general concept down of that we have to complete the square to finish these problems. And we will go over all of this in detail tomorrow. All right, have a good night.